We can see you, and we can see your presentation. Can we hear you?
I hope you can hear me, although you might enjoy it better if you couldn't. So.
Well, the good news for us is we can hear you. Please go ahead.
Okay, thank you. First of all, thanks to everybody at CERTI for accommodating my schedule here and having to dial in remotely. I do wish I could be out there with all of you, not only celebrating the 50th anniversary of the Apollo 11 splashdown yesterday, but also celebrating 10 years of LRO at the moon. It's been quite the decade. As the years progress, it falls further and further into the back of my mind, but I do recall being at then the NLSI forum in 2009 and really getting to see the first images of the moon from LROC at that first CERTI forum or NLSI forum back in 2009. So here we are a decade later, and we're going to be looking forward to the next decade of lunar observations as we go into the 2020s. This is a really exciting time for lunar science, for planetary science, and I'm just thrilled that LRO has been able to survive to be a part of it. I'm going to give you a little bit of an update as to what's going on with LRO right now and our status. I like to update the community as much as possible as to what's going on with the mission. We had some excitement last week. Not only were we celebrating the Apollo 11 mission, but we also were going through a partial eclipse on July 16th. These eclipses have become not only operationally important, but of course also scientifically important. During this partial eclipse on the 16th, we kept the Diviner instrument on so they could measure the cooling curve as a portion of the moon went into total eclipse. We take great precautions with the spacecraft as we lose the sun for a portion of time. We turn off all of the instruments, in this case, except for a Diviner, and we preheat the spacecraft so that we basically can sustain the health and safety of the instruments and spacecraft throughout the course of the eclipse. Fortunately, the next year or so, or a year and a half, sees only a few penumbral eclipses in 2020. And then in May of 2021, we go through our next total eclipse. This is a very short total eclipse, only 14 and a half minutes of totality. But even then, we'll have to take precautions with the spacecraft and as we go back into eclipse season. These become very important operations for us as our battery has now aged, as we all have more than 10 years ago. I hate to think how operationally deficient I am after 10 years of being associated with LRO, as well as being a parent. But the spacecraft continues to operate quite well, and so we're excited for these opportunities as we come forward. The other thing that's been going on is we're waiting for the results of our senior review. We submitted, as many of you recall, discussions at LPSC of this. We submitted our Extended Science Mission 4 proposal in mid-March. We had a face-to-face review in May. I believe it was May anyway. July has been a heck of a month, or a year as it feels. And we were supposed to be notified in the beginning of July the results of the senior review, although as we've learned from the MEPAG group, there are some delays in reconstituting the advisory committee that will consolidate the comments from the senior review, and that won't happen potentially until September. So we're eagerly awaiting those results as we plan for the future of LRO beyond October of 2019. We anticipate good results, but of course we're eagerly awaiting the word from headquarters to be able to move forward. Some recent excitement was that we've now got not only the support of the Planetary Science Division, but of course the Lunar Discovery Exploration Program. This is providing us an opportunity to interact with commercial lunar landers, working with them to identify and characterize landing sites. And so we're very eager for this opportunity, a new set of customers waiting and using LRO data. And of course, we continue to operate in supporting international landing site characterization. We were all disappointed that the bare sheet landing did not occur successfully, but we were very satisfied with the way that interaction with Israel worked, and are eagerly awaiting the results of the Chandrayaan-2 landing in September. Of course, we also are working very hard at supporting the human exploration program and identifying, characterizing landing sites for 2024 and beyond. Just talk a little bit about the future of LRO. I always show these charts. I know I think Carly's at the forum, and so she'll appreciate seeing these spectra, except they're the spectra of our orbit and how they've evolved over time. This serves as a reminder, of course, that LRO has moved on from its circular orbit that we were in the first roughly 2 years of our operations. And we've really turned the keys of the spacecraft over to Sir Isaac Newton and the Grail spacecraft as well. We use the information we have about the gravity signature of the moon to drive the spacecraft in its orbit as we slowly make our way to a roughly 100-kilometer circular orbit in the next few years. This, of course, takes us away from the South Pole, but lowers our periapsis over the North Pole. Our apoapsis over the North Pole. And this low fuel use orbit allows us to maintain an amount of fuel on board, roughly 20 kilograms of fuel on board, that we can use to perform momentum unload maneuvers, but also phase our orbit so that we can be better positioned to observe landing events or planned impacts, things like that. We feel that this maintenance of our orbit is not only the best use of our science reserves, but also puts us into a good position indeed to support future landings and landing observations. Okay. Now, one of the outcomes of being at the moon for a decade is that our slow drift away from the pole, and if I move forward a slide, you'll see that is evolving. So here we are in the middle of 2019, and our inclination is at about 86 degrees. What that means is that we no longer pass directly over 90 degrees south of latitude, or north of latitude for that matter. We have at about a rate of about a half a degree per year, slowly evolving away from the south and north poles. The integrated effect of this is that basically we get these, as we've called them informally, ring of fire. This is a plot looking straight down on the South Pole. The colors indicate essentially a cumulative amount of time spent above a particular location. And you can see we get this density of coverage in a ring that's about 86 degrees of latitude, not exactly 86 degrees, but roughly revealing sort of a bald spot over the South Pole. Now, this has the benefit of densifying our coverage, our measurements in areas away from the pole. So remember, we've been at the moon for 10 years. So we can imagine if we had an integrated map of this, that there would be this incredibly red density of measurements going over the South Pole. This gives us greater coverage, greater time measurements in areas away from the pole, but it also means that we no longer get repeat coverage of areas right at the pole. It takes some slews to make observations of the pole, and as time marches on, our ability to make observations, direct observations of the South Pole get fewer and far between. So that's why right now is a critical time for us to be making any observations of the South Pole that we can when we have the opportunity to do so. I know that the LROC team has been continuously imaging the South Pole as often as they can through large slews. So this is a very important time for us right now to make as many of these observations of the critical landing sites for future support. But again, this is not to say that we don't have, we have 10 years of data already collected and a really excellent density of coverage of the South Pole already in the can. Moving forward with our fourth extended science mission, we've adopted a sort of a theme-focused approach for how we characterize our mission along three main areas. Volatiles, of course, and that's led by Kathy Mant. And in identifying volatiles, we both look at sort of the global scale volatile inventory as well as the targeted lateral and depth study of polar volatiles. We've integrated the mission this way, one, to try to begin stripping away instrument by instrument investigations, instead looking at more universal themes across the 7 instruments, really trying to bring LRO together as one as opposed to 7 separate sets of investigations. We continue our investigations into volcanism and interior processes. Julie Stopar at the LPI is championing that, as well as our ongoing study of the impact history and regolith evolution of the moon. I think there's no finer example of that than the continued investigation of regolith formation and churn through the observations of LRO era impacts. Used to be that just the LROC NAC instrument was able to detect surface changes. Indeed, now we're seeing changes in multiple data sets as a result of our extended baseline of observations. And so with 3 more years of LRO observations, we're going to be building upon our already incredible data set with 3 more years of valuable observations of ongoing activity at the moon. We also, of course, are, as I said, turning our focus to the South Pole and continuing our support for not only scientific investigations at the South Pole, but supporting Jake and investigations supporting the HEO program and our Artemis program with the return to the moon in the next couple of years. This is one of the more exciting areas that, when LRO was envisioned, of course, we were there to chart safe and interesting landing sites for human and robotic explorers. And so I guess what comes around goes around. And so we're glad to be doing that role again for the Artemis program, as well as for the LDEP program. This is a visualization produced by our scientific visualization studio here at Goddard, showing a day in the life of the Shackleton Crater region, just a random day or series of days in 2024. What most excites me about our opportunity is that as the targets, as the areas of exploration get identified, we can, in a very swift manner, where we're capable, is to image and identify additional data sets to collect for supporting these future landing sites. I'm sure a number of you in the crowd are well familiar with our vast array of lunar data sets. We have a number of specific polar data sets that we've produced over time. The LOLA DEM at 5 meters per pixel, and an example of a hillshade version of that data set is shown at the right. This is at 5 meters per pixel at latitudes greater than 87.5 degrees. The USGS hosts a series of NAC DTMs around the South Pole. It's not a continuous DTM, but of targeted areas. At 4 meters per pixel, these have been very valuable data sets as we assess landing sites. And of course, our diviner temperature data sets, both maximum, minimum, and average temperature maps for the South and North Poles have been widely used. LAMP provides both on and off band ratio maps, which have been useful for identifying potential volatile rich areas. We also, of course, have radar mosaics from the Mini-RF instrument from their first 2 years of observations using the onboard transmitter. The LOLA team has produced a number of illumination Earth visibility maps. The LROC team has produced their version of illumination and maps as well. So we have no shortage of products that are useful for polar studies. Not only have we been preparing for future exploration through the production of this really incredible data set, we also, in my mind, one of the more valuable things that LRO has produced is a workforce that's been trained on lunar science throughout the life of LRO now. There's an entire generation, myself included, that have essentially grown up and raised on the LRO mission. Each instrument has a number of scientists, team members who either are now in leadership positions. You saw Ben Greenhagen's presentation the other day. He's a perfect example of someone who's grown up and now is in a leadership role. I think speaking for the LRO team, particularly the early career and mid-career folks, we are well prepared and very eager to participate in the Artemis generation itself. There's no finer example of how early career folks have contributed to LRO than the statistic that 40% of all of our publications are over 300 peer-reviewed publications that have come out of LRO have been authored by early career scientists. Just as a reminder, every 3 months we deliver data to the PDS. In fact, over the last several months, LROC has been delivering every month. That reduces the overall volume of their deliveries in one big chunk and breaks it up into more bite-sized morsels. Hopefully everyone is familiar with the Quick Map tool that the LROC team hosts, which supports a number of LRO data sets as well as other historic LRO lunar data sets that you can interact with. This is just a video. We talked about Tsiolkovsky the other day in Belbatki's talk. This is an overlay of the rock abundance map at a perspective view over Tsiolkovsky. It's an excellent opportunity to interact with our data sets and learn more about the wide array of data that we have. I list there, for example, other resources, web sources for downloading and finding our data sets. And again, as always, if anyone has questions about finding our data, don't hesitate to reach out to me or anyone else on the LRO team.
3,000 feet.
Now, this is a product that the LROC team produced recently, released last week, a visualization of what the lunar module Eagle saw, the astronaut saw on their descent. And of course, the excitement of this was the first time ever since Neil Armstrong observed it, the opportunity for us to ride along with him. Now, what was most remarkable about this product is not only that it showed for the first time for us to enjoy what Neil saw, but I think it also highlights the capability of this data set. We can visualize the descent and landing, the final stages of a landing for future explorers.
This becomes critical as we prepare for not only Artemis, but ongoing exploration after that, to better train and prepare the astronauts for getting to the surface of the moon. So in a moment after the preamble here goes off, you'll actually see, this is the full spectrum, not just illuminating from one or both of the windows, but the whole field of view. And of course, that left there is West Crater. So what most excites me is that this is showing the possibility for supporting future exploration and really the use of LRO data, not just as a scientific tool, but also as a training tool for our future explorers. Now, as much as it pains me to stop this midstream, this is, of course, a video that's available on the LROC website. I encourage everyone to go to that. The LROC team reports that their traffic has doubled in the last week since the release of these videos. So just to close, of course, the last week has been an incredible time for lunar science, not only reflecting on the past of what we accomplished collectively 50 years ago, but also allows us to look forward to the future. And I am so excited for the opportunity that LRO has to support this new endeavor, and we look forward to 3 more years in lunar orbit and punishing everybody with 3 more years of me reporting to the community about the wonderful things that LRO is doing. With that, I'll pause and hopefully have a few moments for questions. Thank you.
Thank you, Noah. I think we could do one question. We're running a touch late. Anyone? Well, it seems everybody who has been visiting your site is well aware of what LRO has been doing. But we thank you very much for your time and the presentation, and we will move on to the next talk. Thank you.
Great, thanks so much.